So exercise related to the graphs and motion. We'll do the question from this. Starting with question 7. Two graphs are there. One is a speed time graph. Another one is both are speed time graph, but showing different trend. Describe the motion of object shown in graph in figure 1.1. What it shows in 1.1? What we can
Constant
say?
acceleration.
So we can say it has a constant acceleration because it's a this is a straight line. So whenever it's a straight line, we can say that it has a constant acceleration, or you can also say constant changing speed. Because acceleration refers to changing speed. So constant changing speed or constant acceleration. What about the motion of an object in figure 1.2? What you can say about acceleration?
Decreasing acceleration.
Increasing speed, but speed is increasing. How we know speed is increasing? Even here also speed is increasing, but with a constant rate. Here speed, the increase in the speed is decreasing, or we can say that this is decreasing acceleration, or decreasing acceleration, or the increase in the speed is decreasing. So the points which we'll mention, the first one, we can say it has a constant or uniform acceleration. The second one, it has decreasing acceleration. And what is common thing in both graphs? One is constant or uniform, and the other one is decreasing. And the other one is decreasing, but with increase in speed. Or we can also say speed increase here. And we can also say for this one also increase in speed. So both graphs shows that speed is increasing. And if I sketch the result, like how it appear in terms of values, say an object was having a speed of 3 meters per second. Then it changes to 6 meters per second. Then it changes to 9 meters per second. Then it changes to 12 meters per second. So the speed is increasing, but the increase in speed is same every time. So acceleration is 3 here, acceleration is 3 here, and acceleration is 3. So acceleration is same for the motion, but the speed is increasing. What about the second graph? The second graph shows that the change in the speed is decreasing. Speed is increasing, but the change in the speed is decreasing. How? Like example, say it was 3 meters per second, then it turned out to be 10 meters per second, then it turned out to be 15 meters per second, then 17 meters per second. So how much is the change? 3 become 10, so that's 7 acceleration, 10 become 15, 5 acceleration, 15 becomes 17, 2 acceleration. Like the change is 2. So here acceleration is decreasing, but the speed is increasing. Here acceleration is constant and the speed is increasing. Is it clear? Anyone having a doubt or a question in this?
No, sir.
Okay. Moving on to the next question, question 8. In question 8, a bus travel at a constant speed and it stopped for a short time. Then it travel at a higher constant speed. It's a distance time graph, and recall for a distance time graph how we represent a constant speed. A constant speed in a distance time graph is a straight line. Look, in a speed time graph, if there was a speed time graph and they asked show a constant speed, so how we represent a constant speed? In that case, we represent by a horizontal line in a speed time graph. But in a distance time graph, it is a straight line with a constant gradient or a slope. So a bus is traveling at a constant speed, so we draw a straight line with a constant gradient or angle. Then it stops for a short time. So if it stops for a short time, distance time graph, how we represent that the object is stationary? So we draw a horizontal line that the distance does not change. But they mention it's a short time interval. So length of this line should be shorter. And then it travel at a higher constant speed. Speed is constant but higher. So how we represent a higher constant speed? So we make much steeper line or a greater gradient, which shows that the speed of this object is constant but a higher constant value. A lift with elevator starts from a rest at the ground. Figure 1.2 is a speed time graph. Use the graph to determine the distance. How to calculate a distance from a speed time graph? Whenever you have a speed and time graph and you want to calculate a distance, the formula is area under the graph. Like what area is under this whole graph, that is called a distance travel. So how we can calculate a distance travel? You can divide this into different shapes. If I draw a line here, this is one triangle. If I draw another line here, this will be the second triangle on the right hand side, and between them is a rectangle. So here we have rectangle, this part. Here we have a triangle, one, and this is a triangle, another triangle. So we calculate the area of each shape. So what is the area of the triangle? The formula for area of triangle is half base multiplied by height. So it will be half. What about the base here? This is the base of a triangle. So when you check how to know 10 boxes, 10 boxes equals to 5. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes equals to 5. So each box equals to 0.5. Because like if 10 boxes are 5, one box is equals to 0.5. So each box is 0.5. So after 5, this will be 5.5, then 6, 6.5, 7, and then it will be 7.5. So this is 7.5. So base is equals to 7.5. And what about the height of the triangle? Like this hole is the height of the triangle. And this one is a base. So what about the height of a triangle? This was 3. And how to know how much like each box stand for? 10 boxes equals to 1. So one box is equals to 1 divided by 10, which is 0.1. So this is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and then become 1. So after 3, 3.1, 3.2, and 3.3. So 3.3 is the height. So this will be 3.3. What's the answer? 7.5 into 3.3 divided by 2. What is the area of this part? 7.5 into 3.3 divided by 2.
12.375.
So area of this part is 12.375. But this is area of the first triangle. We have to calculate the total area. Now we'll calculate area of this second part. How to calculate area of a rectangle? It will be length into width. What about the length? It is starting from 7.5. It is starting from 7.5 and ending at 20. So how much? What's the total length? So it will be 20 minus 7.5. So this length will be 12.5. And what about the height of this? The height will be same as 3.3. So to get the area, it will be 12.5 multiplied by 3.3, which is equals to 41.25. So 41.25 is the area of this part. 12.375 is area of the first triangle. Now we'll calculate area of the last triangle, which is half base into height. So half, what about the base? It is starting at 20 and ending at 25. So that's equal to 5. And height is same. It's ending at like, this is the same height as 3.3. So this will be 3.3, which is equals to 8.25. So this answer is 8.25. But now the question is, what is the total distance travel? So total distance travel is area of all the parts. So the first part area was 12.375. The second part area was 41.25 and the third part area was 8.25. We add them to get the total area.
61.875.
So 61.875, and if speed is in meter per second and time is in second, the final answer will be meters. So we'll get the distance as 61.875 meters. Is it clear? That is speed time graph, how we work out the distance travel?
Yes.
Anyone having a doubt or a question? So speed time graph, you always take area under the graph to calculate the distance travel. Usually in the answer key or the marking scheme, the rounded off answers are there. So like if 61.875 is there, so you might see in a marking scheme as 62. But it is fine if you write your answer in three significant figure, like you write at 61.9 or you write at 61.87. That's fine. Moving on to the next question. Question 9, figure 1.1 is a speed time graph. So look, for a speed time graph, there are different shapes of the graph depending on the condition. Like example, so if we have a speed time graph, on x-axis we have speed, y-axis time. And if we have a horizontal line on x-axis, what it means object is not moving, rest. If it is a speed and time graph and it is a straight line passing through the origin, so what we can say, or before that, if it's a speed time graph and it's a horizontal line parallel to x-axis, so what we can say the object is having a constant speed. If it's a speed time graph and it's a straight line with a constant gradient, so speed is increasing, but we say the object is having a constant acceleration. If it's a speed time graph and it is having a curve, so what does it mean? It means that the acceleration is, it is accelerating and acceleration is increasing. If it's a speed time graph and the slope is decreasing for a graph, then what we can say or conclude, we can conclude that the acceleration or the change in the speed is decreasing. Then we might have a decreasing speed. Decreasing speed, three possibilities are there for a decreasing speed. It might be a constant decrease in speed. It might be an increasing deceleration or decreasing deceleration. So we have a speed time graph. If it is a constant deceleration, then speed will decrease, but it will be a straight line. So whenever there's a straight line, we can say that object is having a constant deceleration, like constant change in speed. If it's a speed time graph and the curve like becoming horizontal or turning to horizontal, so we say that here deceleration is decreasing, or we can say decreasing deceleration. And if it's curve getting like this, So we call that as an increasing deceleration. So even a deceleration can be constant, decreasing, or increasing. First, it's a horizontal line here. Till this point is a horizontal line. What we can say? If it is a horizontal line, what we can say here about the motion of the object?
Constant speed.
So we can say it has a constant speed, or we can also say it has no acceleration or zero acceleration. That's the first part. If you see this part where it is approximately a straight line, till this point it looked like a straight line. What you can say about this object?
Constant deceleration.
Constant deceleration. So this point, it has a constant deceleration, or deceleration is like speed is decreasing, but every time same decrease in speed. But when you check the third part, it is getting curved. Speed is decreasing, but it is getting curved. So what you can say about this part?
Decreasing deceleration.
So we can say it is decreasing deceleration. Like speed is decreasing, but the change in the speed is also decreasing. That's to make you understand how the shape of a graph explain the motion. So speed time graph, we can use it to explain the motion. Now, moving on to the question part, explain what is meant by deceleration. So what we call deceleration, or what is the definition of a deceleration? The term deceleration means decrease
in speed.
in speed. Whenever objects decrease in speed, we call deceleration. Or we can also say negative acceleration is also known as deceleration. Then the second part, the distance traveled between 3 seconds to 6 seconds. It's a speed time graph, so we have to take area under the graph to work out the distance from 3 seconds. So this is 3 to 6 seconds. So from 3 seconds to 6 seconds, actually it will make two shapes. One is a triangle because area under the graph. So area under the graph, if I draw this horizontal line, so what it will form? It will form two shapes. One is the triangle and another one is a rectangle. So this one is a triangle. And the other one is a rectangle. So we have to first work out the distance, area of the rectangle, then area of a triangle, and the total will be the sum. So how to work out area of this triangle? What's the formula for triangle? It is half
base into height.
Base into height. So what is this base? It is starting at 3. Yes, you can also use trapezium. If you combine triangle with rectangle, it will form a trapezium. You can use a formula for area of trapezium as well. It will give you the same answer. But I prefer to divide the figure into simple and work out the area of each of them. So this one is 3, starting at 3 and ending at 6. So if it is starting at 3 and ending at 6, so what is the length of, or the base? That's equal to 3. And how much is the height? It is starting from 5. If you see here, it's starting from 5 and it is ending at 11. So if it's starting from at 5 and ending at 11, so what is the height?
6.
6. So because it's not starting from 0, it's starting from 5 and ending. So the height is equals to 6. So we'll use the formula half base, which is equals to 3 and height is 6. So 3 multiplied by 6 makes 18 and divided by 2. So what we will get? We will get
9.
This as 9. So area of this part is equals to 9. We calculated. Now, area of the rectangle starting at 3 and ending at 6. So this will be 3. Starting at 0 and ending at 5. So this will be 5. So how to get the area of the rectangle? It is length into width.
Length into width. So answer is 15.
So length into width, length is equals to 3 and width 5 example. So answer is 15. So one of the answer is 9 and another one is 15. So what is the total? Because they asked the total distance travel. So we'll just simply sum them. It will be 9 plus 15, which makes 24. And if the speed is in meter per second and time is in second, the unit will be meter. But if the speed was in kilometer per hour and time was in hour, then the unit will be kilometer. Or if speed is in centimeter per second and time in seconds, so answer will be in centimeter. So we divide the figure into parts and calculate the area of each part and then sum to get the total distance traveled. Is it clear, this part?
Yes, sir, clear.
Then the next, the deceleration. Deceleration means the change in the speed from 3 seconds to 6 seconds. So from 3 seconds to 6 seconds, what is the change in speed? To calculate a deceleration for a straight line graphs, you can use a formula or you can use a gradient as well. If you use a gradient, the gradient will be y2 minus y1 over x2 minus x1. Or you use, for a straight line graph, I prefer that you use a formula. So acceleration or deceleration is change in velocity divided by time. So we need from 3 seconds to 6 seconds. So first, what is the speed when time is equals to 3 seconds? So when time is 3 seconds, what was the speed? It is 11. So the starting speed is 11. When time is 6 seconds, what is the speed? That is 5.
5.
So change in the speed, the final, this is final speed, which is 5, and initial speed is 11. So it is always final minus initial. For if it is a curve, you cannot use a formula. You have to use a gradient for curve. If formula is valid for both straight line and the curve, but formula, I mean the gradient is valid for both straight line and a curve, but formula is only valid for a straight line. If it's a curve, you cannot use a formula. So acceleration is the change in velocity, which is 5 minus 11 divided by time interval. So what is the time interval from 3 seconds to 6 seconds? So time is equals to 3. So 5 minus 11, which is minus 6 divided by 3. And minus 6 divided by 3, we get minus 2 meter per second square. So we write as the deceleration or the change in velocity for this one is minus 2. But because they usually ask for magnitude, our answer is minus 2 meter per second square. But if you write 2 meter per second square, it is also correct because they usually ask for a magnitude. And negative I already means it's a deceleration. So you don't have to represent a negative sign again. But it is fine if you show a negative sign. Then state what happened to the size of deceleration after 6 seconds. So what is happening to deceleration, as we already discussed in the beginning, that from after 6 seconds, what was happening to a deceleration? Is it increasing, decreasing, or constant? This part.
Decreasing.
So it was decreasing deceleration. As the curve, the angle is decreasing, so deceleration is also decreasing. This was constant deceleration. And this one is constant speed or no acceleration. So this was these are some questions from graph and motion. Next session, we'll do some different like this exercise, some question from this and some from other exercises. Any question or a doubt related to the session today?